नमस्कार दोस्तों, मैं हूं आपका होस्ट रोहित and welcome to our YouTube channel Rohit's Talk. In our previous video, we have gone through powder testing like burning test, resistivity testing, what is MIT, MI and LIT and related basis of safety video. If you have not gone through this video, I suggested please go through it. Link of video as well as other process safety video shared in description box. Today we learn about how to determine explosive nature of material. So let's begin powder safety part 4 without wasting any more time. Determination of explosive property of material, that is starting material, raw material or finished product. There are various ways of finding out explosivity of material. Explosivity of material can be identified theoretically or practically with the help of lab instrument like for hammer test. However, liquid can't be tested using lab equipment. Hence, for explosivity property of liquid, one shall strictly depend on theoretical method or literature source. Energetic substance in general can be identified by the presence of hazardous molecule structure such as a peroxide group, nitro group, azo group, double and triple bond, ring deformation or steric hindrance, all influence the stability of molecule. The table lists the number of groups that have relatively weak bonds and that releases substantial energy upon cleavage. The list is not exhaustive. The listing does, however, provide the assistance in screening the chemical structure for determining which should be investigated further before considering of handling even in small quantities. The presence of one of the mentioned group in the molecule does not necessarily imply that the substance is hazardous in nature. For instance, a molecule that contains nitro group that attached it to long aliphatic chain does not show significant explosive property. On the other hand, trinitromethane, which contains of 3 nitro group attached to methane group, does have dangerous explosive properties. Diluting the active group by increasing the molecular weight decreases the explosive potential. However, the initial absence of unstable group is no guarantee for long-term stability of compound. For example, some aldehyde and ether are easily converted to peroxide by reaction with oxygen from air. Organic peroxide present a class of unstable material while monomers represent a class of substance that can be self-react by polymerization if not probably inhabited and if temperature is not properly maintained. Determination of explosivity theoretically. Oxygen balance. It is an expression that is used to indicate the degree to which an explosive can be oxidized. If an explosive molecule contains just enough oxygen to form a carbon dioxide from carbon, water from hydrogen atom and all of its sulfur oxide from sulfur and all the metal oxide from metal with no excess, the molecule is said to have a zero oxygen balance. The molecule is said to have a positive oxygen balance if it contains more oxygen than is needed and a negative oxygen balance if it contains less oxygen than is needed. The combustion will then be incompleted and large amount of toxic gases like carbon monoxide will be present. The sensitivity, strength and brightness of explosive are all somewhat depend upon oxygen balance and tends to approach their maxima as oxygen balance approach zero. The oxygen balance is calculated from empirical formula of compound in percentage of oxygen required for complete conversion of carbon to carbon dioxide, hydrogen to water and metal to metal oxide. The evaluation of hazard potential based on oxygen balance is not an absolute rating but only an indicator. Almost all the recognized detonating explosive have oxygen balance between -100 to +40. Any substance with oxygen balance more positive than -200 should be tested as potential high risk and explosivity testing should be carried out. Oxygen balance shouldn't be performed for all chemical can be explained with the help of example MDC. Using the formula OB for MDC can be obtained as -56.5. As per severity scale, MDC fall under high severity, but in reality, MDC is not an explosive. Hence, before taking any material for oxygen balance, exercise has to be checked whether it is candidate for OB exercise or not with the help of previous given table. Determination of explosivity or shock sensitivity of material using BAM fall hammer test. It is very important to know whether a material is shock sensitive or not. Shock sensitive material are to be stored separately with certain condition. This can be measured with the help of an equipment called BAM fall hammer test. It is also known from several sources that every powder or material is not a candidate for shock sensitivity test. A powder or a material is said to be candidate for shock sensitivity test only if it satisfied either of two conditions mentioned. First, an exotherm or decomposition quantifying over 800 joule per gram energy from DSC result. Or second, presence of any explosive group in a chemical structure of molecule, example nitro group, azide group, peroxide group. As mentioned in previous table. Hammer test procedure. A small sample size 50 to 60 mg is enclosed in an impact device. The sample filled impact device is placed over an vial and drop weight is released from a definite height. A drop weight usually weight in the range of 1 kg, 5 kg, 10 kg and a height can be adjusted. A potential energy due to the free fall of drop weight is supplied to a compound and can be calculated. Result and interpretation. The result of this experiment is either positive, that is shock sensitive, or negative, not shock sensitive. But if the result is positive, then potential energy required to create a shock sensitivity can be calculated using a formula P is equal to m into G into H, where P is a potential energy in joules, m is the mass of the drop weight in kg, G is acceleration due to gravity, and H is the height of the fall of the drop weight. Basis of safety. If the material is found to be shock sensitive in nature, then following measures can be taken. Do not store it at height. Do not isolate the material. It is safe to keep the material in solution form. If it is reagent or raw material, then explore for alternative of material. If it is an intermediate, then explore alternate route of synthesis if material isolation is inevitable. If the material is a final product, then it shouldn't undergo any kind of powder processing operation such as a milling, shifting, drying if required to be conducted at utmost care, no FBD or spray drying operations. If specific particle size is required for final product, then during final crystallization step itself it has to be brought and it shouldn't be pushed to a size reduction operation like milling. Finally, this is a flowchart for explosive screening procedure for easy and better understanding and to decide how to approach towards explosivity testing of material. तो आज के वीडियो में सिर्फ इतना ही. If you find this video informative and useful, please like and share the video and subscribe our channel, which will boost our confidence to bring such quality content. Don't forget to press a join button so that you will get notification about our latest video. You can also connect with us on our blog page and Facebook page. Links are shared in description box. तो मिलते हैं हमारे अगले वीडियो पाउडर सेफ्टी पार्ट 5 में. तब तक के लिए मैं रोहित साइनिंग ऑफ. बाय बाय.